Hello, my name is Jino Huang. Today I'd like to present the Jakarta EE 10 migration project for Apache Geode 2.0, one of the most comprehensive modernization efforts in the project history. This migration represents a critical evolution of Apache Geode to align with modern Java enterprise standards and ensure long-term sustainability. Let me start with an overview of what I've accomplished. This project, tracked as Geode 10.466, represents a complete modernization of Apache Geode enterprise Java stack. I've successfully migrated from the legacy javax namespace to Jakarta EE 10 standard, while simultaneously upgrading major framework dependencies. For example, Jakarta Enterprise Edition, it's from Java EE 8 to Java Enterprise Edition 10, which is Jakarta name. And then Spring Framework from 5.3.21 to 6.1.14. Spring Security from 5.6.5 to 6.3.4. And Spring Boot is from 2.6.7 to 3.3.5. Spring Shell from 1.2 to 3.3.3. And we have Jetty, it's from 9.4.57 to 12.0.27. And we have Apache HTTP Components, version from 4.5.13 to 5.3.1. And we have Lucene, version from 6.6.6 to 9.12.3. So the impact is significant. Total about 720 files have changed, with over 18,000 insertions and 10,000 deletions, affecting more than 170 Java files. They were migrated from javax to Jakarta namespace. And I have about 118 command classes updated for Spring Shell compatibility. So most importantly, all more than 10,000 active tests are passing with a 0 compilation errors across all models. So, why this migration matters? The transition from Java Enterprise Edition to Jakarta Enterprise Edition is more than just a namespace change. In 2017, when Oracle transferred Java EE to Eclipse Foundation, they retained the trademark rights to javax package names. This forced the Eclipse Foundation to migrate all APIs to the Jakarta namespace, which created a significant breaking changes in the enterprise Java ecosystem. The timeline is pretty critical. Jakarta EE8, which was announced in 2019, and that was the last version using javax namespace. And 2020, Jakarta EE9 was announced. That is the first version with the Jakarta namespace. That is going to be breaking change. In 22, Jakarta EE10 was announced. So our target version with a new feature and a modern standard here. So why we couldn't stay on the old stack? The first is application server compatibility. Modern servers like a Tomcat 10.1, a Jetty 11, and others have moved to already Jakarta Enterprise Edition 10. And also framework support, like a Spring Framework 5 version 5 has reached end of life. For example, Spring 5.3, the support ended this last year, August 31st, 2024. And Spring 6 requires Jakarta Enterprise Edition 9 and beyond. And currently on Spring 6.1, the support ended June 30 of 2025. but commercial support ends in 2026. And we're going to have to migrate to Spring 6.2. The EOL is at this point June 30 of 2032. So we have plenty of time if we eventually move to 6.2 of a Spring. And there's Jakarta Enterprise 10 version requirement. Spring 6 only supports Jakarta 9 and 10 and beyond. So that's making the namespace migration mandatory. And also there is a security reason. Staying on legacy versions means missing critical security patches and CV fixes. We have to purchase commercial license to update those legacy versions. And there's a vendor support. Industry has consolidated around Jakarta EE as the standard today. And also long-term sustainability perspective, remaining on Java EE would have created technical debt and compatibility issues down the road. So without this migration, Apache Geode would be running on unsupported frameworks with no security updates, making it incompatible with the modern Java enterprise ecosystem. So let's take a big picture here, the scope of this migration. This is not a simple search and replace operation. I wish it was. Let me break down the scope. So let's take a look at affected Geode modules. First one is Geode core, that is heart of Geode with a limited but critical javax usage is shown. And there is a Geode web, that's a core web functionality and the sublet integration. And there's Geode web API, which is REST API interfaces and controllers. And we have a Geode Web Management, which is a management REST endpoint. And we have a Geode Pulse, that's web-based monitoring and the management user interface. And we have Geode GFSH, some people say GFish, so that's a command line shell interface. So I've updated more than 118 command classes for this module. And we have a Geode connectors, that's a JDBC and external system integration module. And we have a Geode 1, that's a wide area network replication module. And we have a Geode Lucene, that's a full text search integration module. The last one is Geode modules, that's a session management modules heavily dependent upon Tomcat and Jetty. So what are the key migration areas? The first one is Jakarta EE APIs, of course, the sublet JTA, JAXB, JCA, mail, annotations, and CDI. And the second one is Spring Framework modernization, that complete rewrite of security configurations were required. And we have a GFSH command framework, that's architectural change from Spring Shell version 1 to 3. That's a big leap. And we have a web container integration, that's JD version 2012 and a Tomcat 10.1 and 11 support. And we have a HTTP client update, that's Apache HTTP Components, version 5 migration. Now let's dive into the Jakarta migration specifics. I completed a comprehensive namespace migration across all Jakarta EE APIs. Let's take a look at individual APIs. The first one is a sublet API. That's from javax sublet to Jakarta .sublet. So that's sublet API 6.0. So all HTTP request, response, handling, and filter and listener implementations are applied. And next one, JTA, that's javax transaction to Jakarta transaction. So that's transaction management across distributed systems. And then we have JAXB, that's javax XML bind to Jakarta XML bind. that's XML binding for cluster configuration. And we have a JCA, that's javax resource to Jakarta resource. That's a connector architecture for data sources. And we have mail, right? The javax mail to Jakarta mail. That's email notification capabilities. And we have annotations, javax annotation to Jakarta annotation. That's dependency injection and lifecycle management part. And we have CDI, that's javax inject to Jakarta inject. That's context and dependency injection component. So the impact is more than 173 files migrated across all modules. Every important statement, every API call, every integration had to be carefully updated and tested. Let's take a look at Spring Framework 6 migration. The Spring Framework migration was particularly complex because Spring 6 introduced a lot of breaking API changes, but it was absolutely necessary for long-term support. So why do we need to upgrade from Spring 5.3 to 6? According to the official Spring Framework support roadmap, Spring 5.3 was released October 2020, and the support ended on August 31st of 2024. Spring 5 only supports Java EE, that is javax namespace, is in JDK 8 to 21, and no longer receiving security patches in open source version. You have to purchase commercial license to get security fixes. And from VMware, extended commercial support is available until June 2029. We don't have any contract with the VMware at this moment. Spring 6 requires Jakarta EE 9 and 10, and that is Jakarta namespace and JDK 17 and higher. Spring 6.0 that ended support in June 2024. Spring 6.1 ended support in June 2025. And Spring 6.2 that will end support in 2026. So we have upgrade to Spring 6.1, but we're going to upgrade Spring further to stay on open source software support EOL timeline. So I had to completely rewrite the security configuration because Spring Security 6 deprecated its entire configuration API. So let's take a look at key changes. I removed the Web Security Configurer Adapter base class that is deprecated and migrated to Security Filter Chain bin pattern. So I changed the annotation from @enable global method security to enable method security, and updated all authorization patterns like authorize request method to authorize HTTP request, and then modernized matchers like from ANT matchers or NVC matchers to request matchers that is required by Spring 6, and also adapted lambda-based configuration syntax throughout the process. So what modules updated? Geode Web API, that's for REST API security, and Geode Web Management, for Management API security, and Pulse, that is UI security, and the Geode Assembly, that is integration test configurations. So this wasn't just a cosmetic change, it fundamentally changed how we configure security in Geode today. So let's take a look at Spring Shell 3 migration, that's GFSH transformation. Spring Shell migration represents the most architecturally significant change in this project. The gem file shell is called GFSH. That's a geode command line interface, underwent a complete transformation. Why is this so complex? Spring Shell 3.0 is a complete rewrite with breaking changes. I had a very grueling work to migrate to this part. So I changed from interface-based to annotation-based components. And it has new command discovery mechanism. And it has different parameter validation framework, and it completely redesigned the system. So, for example, in terms of annotation mapping, the Spring Shell version 1 was using CLI command, but Spring Shell 3.0, it has to use a shell method. Same with the CLI option in version 1 should be changed to shell option. And so CLI availability indicator should be changed to shell method availability. And same with the shell component. The name stays same, but it was interface, and now we have annotation form. So I fixed the parameter validation with the custom interceptors, and also implemented a recursive array parameter conversion, and resolved a lot of Boolean flag parsing issues. Yeah, trust me, there are a lot of them. And I fixed the enum type conversion and corrected the region path handling. So result, yeah, 836 out of 836 tests are passing. So 100% working now. Let's take a look at Jetty 12 upgrade. Jetty upgrade was critical for Jakarta EE 10 compatibility, but it came with significant changes. So I upgraded Jetty 9.4.57 to 12.0.27, and there was a namespace change from org Eclipse Jetty to org Eclipse Jetty EE10. So let's take a look at key architectural changes here. The first one is handler architecture. It used to be handler collection. Now it's a handler sequence. And there's a change in class loading strategy. I implemented a server class pattern for web isolation, and this ensures the proper class loading boundaries between the container and web apps. And sublet context management. I fixed the attribute handling with a custom sublet context listener, and resolved a lot of issues with the Spring jar duplication that caused sublet container initialization failures that caused a lot of stress to me. So let me share the critical fixes I made. The first one is a class loading conflicts. The Jakarta Sublet API was being loaded from both container and the web app class loaders. So the solution was I had to configure Jakarta Sublet API to load exclusively from container class loader. So the result is I fixed the web app first class loading consistency. The second issue was with SSL endpoint identification. The problem is Jetty 12 enforces RFC 6125 compliance for SSL certificate. So the solution was to generate dynamic certificate with a Docker IP SA end. So now all SSL, TLS endpoint tests are passing. I'm so happy about it. So what are the affected modules? Geode Web, that's a core web infrastructure, and Geode Web Management. So there is a Management REST API, and Geode Pulse, that is a monitoring user interface. So the Jetty upgrade ensures that the Apache Geode can deploy in modern sublet containers while maintaining backward compatibility where possible. Let's take a look at Apache HTTP Component 5 migration. The HTTP client library migration affected how Apache Geode communicates with external systems and manages internal REST operations. So dependency updates are HTTP client version 4.5.13 to 5.3.1, HTTP core version 4.4.15 to 5.2.4. And also added HTTP core 5-H2 5 to 4 for the HTTP2 support. Why does this matter? Apache HTTP Component 5 is a complete rewrite with asynchronous first architecture, HTTP2 support, modern SSL, TLS handling, and better connection pooling, and also improve the performance and resource management that will be needed for Apache Geode project. So I migrated all HTTP client code to new API, fixed the SSL configuration with a new connection manager architecture, and updated response request handling patterns, and also fixed the redirect and cookie handling, and updated 21 files across multiple modules. So this migration ensures that the Apache Geode can communicate efficiently with modern HTTP-based services. Let's take a look at Tomcat session module. This is the most significant breaking change for end users, so I want to give it special attention. So what changed? Geode module Tomcat 6, 7, 8, and 9, they're removed because they all use javax servlet namespace. So I added Geode modules Tomcat 10 that uses Jakarta servlet 5 and 6 APIs. So now we support Tomcat 10.1 that uses Jakarta servlet 5.0 that requires Java 11, and Tomcat 11 that requires Jakarta servlet 6.1 and is also Java 17, which we are on currently. So why does this breaking change necessary? Tomcat 10 or 10.1 and beyond uses Jakarta servlet instead of a javax servlet. So there's no compatibility layer. These are fundamentally incompatible APIs, so we cannot support both simultaneously in the same module. So let's take a look at implementation details. I made the Delta session manager abstract, and that extracted the version-specific method and that allows future Tomcat version support without breaking changes. And also implemented a serializable principle. Tomcat 10 and beyond remove this class, so we had to implement it for session serialization. And that was 27-year-old deprecate APIs. So I cleaned up Sublet 2.1 era code and modernized the current Sublet standard. So what does that mean to you? So for Tomcat 9, 6, 7, 8, 9 users must remain on Geode 1.0, and there's no upgrade path available. For the Tomcat 10.1 and 11 users, then you can use Tomcat 10.1 or 11. You can also migrate from older version of Tomcat to the modern version of 10.1 and 11 and beyond. Then you can use new Geode, probably version 2.0 and beyond of Geode. So now all session replication tests are passing and verified with both Tomcat version 10.1 and 11. So this is a mandatory upgrade for users wanting to move to Apache Geode 2.0 with a Tomcat-based session management. There's no backward compatibility option I'm so sorry about that. So let's take a look at the rest of framework upgrade. The first one is JLine integration. I migrated from JLine version 2 to 3.0 for terminal handling, and upgraded GFSH history to extend the default history. And we wrote GFSH unsupported terminal to extend a dumb terminal, and fixed the headless GFfish for distributed testing environments. And what about Geode Lucene 2.12.3? So I upgraded from 6.6.6 to 2.12.3. That is 3 major version jump, rather it's a leap. And fixed the artifact naming from analyzers to analysis. They named the package name somehow. And update the command region path formatting, and all Lucene integration tasks are passing. I'm so elated about that. And other upgrades include micrometer upgrade to 1.14.0 and SLF4J. Now we have 2.0.17, and Commons IO. Now we have 2.18.0, and Geode time we have version 2.12.7. So these upgrades also they're minor, but they ensure Geode stays current with the ecosystem while maintaining compatibility. So let's talk about testing and validation. Yeah, there are more than 10,000 test cases I had to deal with. So all of them passing. For example, GFSH, there are about 830 tests passed, and that's total. And connectors have about 500, and Geode Web API has about 100, and Geode 1 and Geode module session all passing successfully. For Spring Shell 3 upgrade, I fixed the command registration and the discovery mechanism, and also implemented the custom parameter validation, and added array parameter support with the recursive conversion, and fixed all the elimination parsing, and updated GFSH parse rule for Spring Shell 3 compatibility. Let's talk about bug fixes and improvements. One of the critical fixes is the session replication. I fixed the session replication integration JUnit test, transaction manager invalidation, and resolved the JNDI binding retrieval in the list JNDI binding function test. And for the JMX compatibility, I fixed the JMX module access for the Java compatibility, and also resolved issues with the internal package access restrictions. Regarding Spring jar duplication, I fixed a sublet container initializer failure caused by duplicate Spring jars, and properly isolated web app class sorting in Perl as well. So regarding REST API issues, I fixed the trailing slash handling. There are a few, for example, in the REST region API integration test, and also corrected the multi-part upload and deploy management integration test. For the GFSH parser, I fixed the negative number handling and corrected the parameter parsing edge class cases as well. Regarding SSH and TLS enhancement, in order to, in compliance with RFC 6125, I fixed the dual server SNI acceptance test for Jetty 12, and also implemented dynamic certificate generation with the Docker IP Essence, and removed the incompatible DNS trust flags. Regarding SSL endpoint identification, I properly configured the SSH for modern TSA requirements, and now all SSH tests are passing. Then let's take a look at security enhancement. Critical aspects of this migration was addressing security concerns flagged during a code review. So there was CFRF protection configuration. So I received the CodeQL security alert about cross-site request forgery protection. I fixed that. And there's another CSRF flag for the web UI. And that was all addressed. Let's take a look at breaking changes. Let me clearly summarize what users need to know about compatibility. So for Tomcat session management users, it is mandatory to upgrade to Tomcat 10.1 or 11 to use new geode. And there are changes in geode modules Tomcat 10, and you need to update all import from javax sublet to Jakarta namespace. And I'm so sorry that rolling upgrade is not supported. You have to do a big bang upgrade. For GFSH users, so command should work identically and improve a lot of command parsing. So there should be no problem at all. For application developers, you need to update all javax imports to Jakarta. You need to review Spring security configurations. If you have a customized configuration, you have to do that. And you need to update HTTP client code if you are using HTTP component directly. And you should verify JMX access pattern for Java later version of module compatibility. So there's a binary compatibility issue. So it's not maintained because Jakarta Enterprise Edition migration is a breaking change. And the source code compatibility is broken because we have changed the import. And the runtime compatibility is limited because we're introducing Tomcat 10 and beyond instead of older Tomcat version. So let's take a look at technical highlights and improvements. So from the architectural enhancement, we have a server class pattern that improved the web app isolation for clean class loading. And we have sublet context transfer, that's for proper attribute handling through listener pattern. We have completion provider framework, that is extensible tab completion system. And command manager refactoring, and I modernized for Spring 3 integration. We have structured logging, so now it's a machine parsable logs with a log for J2 markers. So regarding build system enhancement and configuration cache enabled for the faster builds, and dependent management, centralized version management, and resolve the intermodule dependency issues, and also updated expected artifacts for Maven publishing. While this migration is complete, there are areas for future enhancement, of course. So potentially we will have to move to Java 21, and we need to explore project integration for the virtual thread, and also full adoption of Spring Boot 3.0. And we need to look out for next version of Jakarta EE, of course. And we need to profile and optimize Apache Geode with the new frameworks. So a lot of work to do here. So we need to review migration guide for users upgrading from Geode 1 to 2. And we need to update API documentation, and probably need new examples for Jakarta EE integration. And perhaps session management, migration cookbook, and security configuration best practices that I can think of. So what I have learned from this project, it was grueling work, but it had to be done. I'm so happy that's behind me. So what I learned is technically, so I start with dependencies. So upgrade framework dependencies in correct order. That's very important. I've learned my lesson. So first step is a Java version upgrade, and then Jakarta EE API upgrade, and Spring Framework, and then application-specific library. That's going to be the last one. Most dreadful part was test infrastructure, the updated testing framework before application code. So ensure that you can validate changes incrementally and catches breaking changes early. One of the important lessons I learned was incremental migration. Break large changes into bite size in logical chunks. So namespace changes separated from API changes, and module by module approach, and feature flags for gradual rollout. And the last part I didn't anticipate was static analysis tools. There is a code QL running and GitHub action. And there are, of course, false positives. That's very common with this large project. And we should document the security decisions and policies thoroughly, and should maintain comprehensive test coverage. So process-wise, I learned as documentation is critical. So I made sure comments are explaining why, not what. That's self-evident in the source code, so we don't need duplicacy. And migration rationales for breaking changes and test changes documentation. For backward compatibility consideration, some breaking changes are unavoidable, as you can see, and I should clearly communicate impact to users, and also provide a migration path where it's possible, and support older versions during transition period if it's doable. So it's very important to have community engagement. So early communication about breaking changes and beta testing with the key users, and clear deprecation warnings and migration documentation for assistant. So what are the impacts and the benefit of this project? So immediate benefits are like a modern framework support that is compatible with the latest Spring, Jetty, Tomcat. And one of the most important things is security updates. We have access to latest security patches and fixes now, and performance benefits from optimizations in new framework versions. And we have Java 17 support, ready for modern JDK features, and we'll be shooting for Java 21 pretty soon. And they are all aligned with industry standard Jakarta Enterprise Edition. So what are the long-term benefits? First is sustainability. So no technical debt from legacy frameworks, and security, continued security support for years to come. And there's innovation. So we can adopt new Java features and patterns without our hands tied behind us. And new ecosystem is ahead of us, right? So better integration with the modern Java tools. And we will have a much better interface to our developer community. Easier to attract new contributors because we are using the modern Enterprise Edition 10 and JDK 17 and beyond. So they should attract more new contributors to our project. So what does that mean for our Geode developer community? That ensures Geode remains viable for new project, right? I don't think anybody is considering Java 8 or javax, Java E8 for the new project. And reduces barriers to adoption, and positions Apache Geode for future growth, and also maintains compatibility with the enterprise Java ecosystem. So let's take a look at statistics. So we have 720 files changes and more than 170 Java files changes, and we have 118 command classes updated, and we have 21 files updated for Apache HTTP Components version 5 upgrade. And framework version jumps, right? Spring 5 to 6, Security 5 to 6, Jetty version 9 to 12, Lucene 6 to 9, Spring Shell 1 to 3. So what are the metrics here? So we have more than 10,000 tests passing, 100%, and 0 compilation errors and 0 test failures. We have large portion of code coverage, and we will be ready for the next chapter for Apache Geode project. Looking back, this migration required extensive coordination and careful testing. I want to express my gratitude to Sai Bulagada and Arnold England. I'm sorry I pronounced your name, Arnold and Sai, for their exceptional code reviews and thoughtful feedback and collaborative support throughout this project. Their expertise and attention to detail helped ensure the quality and robustness of this migration project. So the key focus areas were maintaining task coverage. I made sure that no functionality was lost during migration, and documenting breaking changes. We provided a clear upgrade path for users and build system compatibility. I made ensure that smooth integration with existing workflows, and distribution validation. I verified the packaging and deployment processes. So thank you very much for your attention. This Jakarta Enterprise Edition 10 migration project represents one of the most comprehensive modernization effort in Apache Geode. By successfully migrating more than 700 files and all those major modules, updating 6 major framework dependencies, and maintaining 100% test coverage with 0 compilation errors. I've ensured that Apache Geode remains viable, modern, and maintainable platform for distributed computing. The migration positions Apache Geode for long-term success with aligning with industry standard like Jakarta EE 10, and also enables security updates and patches, and will support modern Java versions 17 and 21 coming soon, and also maintaining ecosystem compatibility. Even though this change introduces breaking changes for some users, particularly those using Tomcat 9.8.7.6, the benefit of staying current with the Java Enterprise ecosystem far outweigh the migration cost. So again, I want to extend special thanks to Sai and Arnold for their thorough reviews, valuable feedback, and support throughout this project. Their insights were instrumental in ensuring the quality and the completeness of this project. Thank you very much for your time, and you're welcome to reach out to me if you have any questions or suggestions. Thank you so much. Bye.